Hello everyone, my name is Aryaan Swain. My topic is software defined networking, also known as SDN. It is a modern networking approach and it changes how networks are managed. Traditional networks are complex and they are difficult to scale. They're hard to control. However, SDN solves these problems. It introduces programmability, it introduces centralized control, and in this presentation, I will explain the concept of SDN, how it works, its architectures, and I will also cover the advantages, disadvantages, and the real world applications. Now, what is SDN? Software defined network is a concept. It separates two main functions. These are control plane and data plane. The control plane makes decisions, it decides where packets go, the data plane forwards packets, and it follows those decisions. In traditional networks, both these functions exist together inside every router or switch. However, in SDN, these are separated. The control plane is centralized, it is placed in the controller. It is called the SDN controller, and this controller manages the network. It has a global view and it has knowledge of the entire topology. Unlike traditional routers, which only know neighbors, SDN has full knowledge of the topology. This improves the decision making as well as the efficiency. SDN also enables programmability. Administrators can control networks using software. However, they do not need manual configuration as in the case of traditional networks. APIs can be used and developers can write applications. These applications control network behavior. Now let's know about the traditional network architecture. In traditional networks, devices are hardware based. Routers and switches operate independently. Each device has its own control logic and each device maintains its own routing table. Protocols like OSPF are used, RIP and BGP are also used for larger networks. Each router makes its own decisions. This is called distributed control. This approach works for small networks but not for large ones. As networks grow, management becomes difficult. Policies must be applied manually on each device separately. This increases complexity, it increases time required, it also causes inconsistency because devices may behave differently. Now, the problems with traditional networking. So, there are many problems with traditional networking. First, configuration is difficult. Large networks are hard to manage. Secondly, deployment is slow. Each device must be configured manually. Third, there is no central control. Monitoring becomes difficult and troubleshooting becomes harder. Even small changes take time, and hundreds of devices may need updates. This increases the human errors, and mistakes become more and more common. Innovation becomes slow. New services take longer to deploy, which negatively impacts the efficiency of the system. There is vendor dependency, which means that devices need to depend on specific manufacturers for proper functioning. This results in another issue, which is that the scalability becomes poor and large data center struggles. So the solution is software-defined network, also known as SDN. So SDN solves these problems as it introduces a central control. The control plane is separated and moved to a controller. The controller manages everything from one place. No need to configure each device. Everything is controlled via software. This reduces complexity. It reduces errors. Automation becomes possible. Tasks can be done automatically and networks become flexible. It adapts quickly. As a result, this is useful for cloud systems, which involve especially large-scale networks. So the architecture of SDN is as follows. SDN has three layers. The first is application layer. It contains network applications such as traffic control and security policies. Second is control layer. The the control layer contains the controller, which acts as the brain and makes all the decisions. Third is the infrastructure layer. This contains switches and routers. They only forward packets. Communication happens through these interfaces. Northbound interface connects applications to the controller, and southbound interface connects the controllers to switches. This layered design is modular as each layer works independently and is not dependent on each other. Now, working of SDN follows this mechanism. So, firstly, the packet arrives at a switch. The switch checks its flow table, and if a rule exists, the package is forwarded. If no rule exists, the switch sends a request. This is called packet in message. The controller receives this request, it analyzes the packet, it decides the best path, and then it sends a response. This is called the flow mod message. This installs a new rule in the switch. The rule is stored in the flow table. Future packets follow this rule and no need to contact the controller again. This improves performance and reduces delay. Now, control plane compared to data plane. So the control plane, there is a separation of planes in SDN as we discussed above. The control plane makes decisions and it decides the routing paths. The data plane, however, forwards packets, it executes those decisions. In traditional networks, both of these exist in each device. However, in SDN, these are separated and control is centralized and data plane is only preserved to switches. So control uses algorithms like shortest path algorithms, for example, Dijkstra algorithm, and data plane uses hardware for fast forwarding. This separation improves efficiency and simplifies the devices. So as we can see, this is a table for comparing control plane with data plane. There is the control plane process is responsible for building and maintaining the IP routing table, whereas the data plane is actually responsible for only forwarding the packet. The control plane makes the decisions about where the traffic will be sent, that is the location, and the data plane only is bothered about the next hop along the path. Control packets are destined to be or to locally originate at the router at the control plane, whereas in data plane they only move through the router. In the control plane, packets are processed by the router to update the routing table, whereas in data plane, the routers only use the control plane built to dispose incoming and outgoing frames. In control plane, the process of learning what we will do before sending the packet or frame. Whereas in data plane, we actually have to move the packets based on what we learn from the control plane. And in control plane, routing is performed, whereas in data plane, only switching is performed. So some examples, it includes HTTP, ARP, DHCP, OSPF, RIP, whereas data plane includes TTL, Telnet, decomputing IP, header checksum, etc. So now we can see the architecture of the SDN controller. It also has several functions such as network management, traffic control, policy enforcement, routing decisions. So this controller is central. It manages the network, it controls the traffic flow and enforces the policies. It has a global view and it knows the entire topology. Algorithms such as Dijkstra algorithm and other shortest path algorithms are used to boost efficiency. It can detect congestion, it can reroute the traffic, and it adapts to failures. It changes as it changes and it handles the changes dynamically. This allows real-time optimization, which is far superior to traditional network models. Examples of version controller include Open Daylight, ONOS, Queue Controller. Now there are two interfaces as we discussed above. There is the southbound interface and the northbound interface. The southbound interface connects the controller to switches. OpenFlow is commonly used. It defines the flow rules. So, for example, we can take a rule match destination IP and forward to port. So, northbound interface connects the applications to the controller. It uses the APIs such as REST APIs. These allow developers to control network behavior, and applications include the firewalls, load balancers, monitoring systems, etc. We can discuss some advantages of SDN. SDN has several advantages. It provides centralized control. As a result, the management becomes easier. Automation is possible, and therefore manual work is reduced. Errors are reduced. Scalability improves. Large networks can be handled as a result. Traffic engineering is possible, and therefore traffic can be optimized and congestion can be avoided, which boosts the efficiency. Security is improved as policies are enforced globally and the downtime is reduced. Now, SDN also has some disadvantages and some limitations. One of the biggest disadvantages are single point of failure, as the controller can fail if it becomes a single point. It's if that is if the centralized controller goes down, the network control can be disrupted unless redundancy is in place. Controller can face a bottleneck problem in large networks. There is a scalability problem related to this bottleneck issue, and security risks exist as the controller is a target. These can be reduced using encryption and authentication methods. Migration complexity is also a big problem in SDN, as with the traditional network takes careful planning and can be difficult to deploy smoothly. Now, some applications of SDN. So, SDN is widely used in data centers for efficient management. Companies like Google use SDN. Facebook also uses SDN. In computing, resources are allocated dynamically, network virtualization is possible, and multiple networks share hardware. Another example is in 5G networks, it supports network slicing. In IoT systems, it manages large devices. It is also used in traffic engineering and security monitoring. Now, to conclude, SDN separates the control and data planes. It enables centralized control, it enables programmability, It improves flexibility and scalability. It simplifies management and it transforms networking from hardware based to software driven. It supports the modern systems like cloud and data centers. It enables innovation and automation, which reduces the chance for human errors and manual labor. SDN is widely regarded as the future of networking and is a massive step of on traditional networks. Thank you.